Before we continue, I wanted to take a second to thank our sponsor, This.Labs. This.Labs is a consultancy focused on helping companies with their digital transformation efforts. And that might sound like a buzzword, but what it means is helping companies align their business objectives with their digital efforts, whether that be replatforming, modernizing, or spinning up new projects. This.Dot has worked with companies like Stripe, Xero, Wikimedia, DocuSign, and Twilio. Check them out at thisdot.co. That's THISDOT.co. All right, now back to our show.
Hello, everybody, and welcome to this special training. Today, we have Nathan Walker with us. Nathan, welcome to the show. Thank you for coming. Thank you for giving us this training.
Thank you so much. Yeah, this is an exciting topic to talk about using Angular to develop VisionPro apps. So a lot of material to dive into.
That's awesome. Anything we should be looking out for in particular as the presentation's going on? Any like super exciting things? Are we going to be talking about NativeScript?
We will talk about NativeScript. We'll touch a little bit on some Swift UI bits. We'll talk about kind of different ways to access like all the things in VisionOS. So, or at least a good fair bit of it. But yeah, feel free to ask questions as we go.
Awesome. Well, why don't you take it away?
All right, let's dive in here. I'm gonna get slides set up here. And get this bar out of my way. There we go. So welcome everybody. We're going to talk about an exciting topic of using Angular to develop apps for the VisionPro. A lot of new things shown here that haven't been covered before. So I want to start slow and we'll go through bit by bit and we'll sort of dissect the Hello World sample that was actually provided by Apple last year at WWDC. And we're actually going to use Angular to develop that and sort of dissect that app. Before I get too deep into the weeds, let's start out slow, and I just want to cover the primarily two ways to get started with VisionPro using Angular. StackBlitz is one. This is good if you have an actual physical VisionPro device, and then the NativeScript CLI. StackBlitz integration works through these templates that are on the homepage. You can choose any flavor of JavaScript there. But choosing Angular here, we can use the NativeScript preview app, which is on the VisionPro store, and you can use that to scan a QR code in StackBlitz. That will actually capture the URL and connect it to the StackBlitz session. And this is Angular 18 running in StackBlitz, and this is now live connected through a socket to the app on the VisionPro. You can make changes inside there, and you'll see those changes update in real time there on the app. Again, it's great to prototype around and kind of explore VisionPro that way. But the other way, which we'll cover really today because you can dive as deep as you want to with the NativeScript CLI. With the latest version of NativeScript, you can create an app using the --vision-ng flag. That will create a template already set up for VisionPro development. And once we are inside of that directory, we can do ns-run visionos and no HMR by default. We can actually use HMR with the embedded flag off, and I'm going to touch on that and we'll show that in a minute. This command can be used for VisionPro Simulator, which comes with the latest versions of Xcode, and you can also, of course, use it with a physical device. When you have a physical VisionPro plugged in, and I should mention they sell a developer cable for the VisionPro, and it attaches on the side of it, and you can actually plug USB-C into the Mac, and it's the way I've developed on it before, and it's nice because you're not dealing with any network connections, but you can get the device ID that way, and you can add that through the -- device flag, and that will run it on the connected VisionPro. This is a snippet of code from the main TS file, the bootstrap of the Angular app into VisionOS, and this embedded flag is important. VisionOS is the first platform that NativeScript supported where it's first-class Swift UI. What that means is it's actually booting your Angular app into a Swift UI app lifecycle. This is important because VisionOS is a Swift UI first-class platform. iOS, of course, has been around for many years, and UIKit had been the predominant way to build apps there. Swift UI is really the predominant way to build apps on VisionOS. But just like with iOS, you can mix UIKit with Swift UI, and we do a lot of that in this development as well. And so we can sort of mix all these techniques to do this. The embedded flag, though, is interesting because when you have it enabled, you don't want to be using HMR with it on. But if you turn embedded off, you can use it. And so let me just demonstrate that here. And I'll give a glimpse of what we'll actually look at here. So I'm going to run exactly that command that we were just talking about. ns-run VisionOS. We'll pass the no HMR flag. And that's going to auto pick up the fact that this VisionPro simulator is running. And it will run here. And this is a basically an Angular built version of the Hello World tutorial. And if I give a glimpse at that, this is on the Apple developer docs for VisionOS. This is a really in-depth sample. And I kind of chuckle when I think about it because it being called Hello World, it is quite a deep Hello World. There's a lot of depth in this app. And all of those things are actually hooked up in play in Angular here as well. Like, for example, if we go to Planet Earth, we can pop the globe out and we can sort of interact with, you know, all of these things. There's sort of menus and you can turn rotation on and all this kind of thing, which is done through scene support in VisionOS, which we'll touch on. But we're going to focus on a couple areas, again, just slow sort of walking into this. And let me talk about HMR for a minute. So let's go back here. There is a doc on the NativeScript docs about developing with VisionOS, and it touches on some of this in here. The flags to create, these are things we just covered. Talks about the developer strap, getting the device ID and using that to develop on it. And most importantly, I think that is interesting on VisionOS is the hover styles. Hover styles are pretty important across VisionOS as you use it because it really helps identify what your eyeball is looking at. It doesn't track your hand movement, but it tracks your eyes. And that highlight is pretty important. So we can actually enable that through this touch manager. The touch manager comes from NativeScript Core, and it was introduced in 8.7, I believe, might have been 8.6. Actually, I think it was 8.6, but this has a bunch of options for these highlights, and that's what this is. So if I sort of move my pointer over here, the pointer is serving as a simulation of the eye. And so wherever your eye would look, you would see those highlights there. We can sort of play around what the default looks like. So I'm going to go into main, and this snippet is what we're focusing on here. We can set globally for the entire app that we want global hover to be on or off. Usually it would be recommended to turn it on because you're going to get some of that stuff for free as long as you have sort of a default highlight set. Let me turn this off and I'll show you what happens. So with that off, close this globe. You can see when I move the pointer, we get no highlights now. Zoom in so you can see that a bit better. But you see there's nothing, so it looks dead, right? That would feel pretty weird on the VisionPro when you're using that, because when you look at your eyeball at this, you would see no highlight there. So there'd be no way to tell what you're actually looking at, and therefore it'd be hard to tell what you can even tap on. All taps in VisionPro are just with the forefinger and thumb. And so that's a super important detail with visionOS development. So highly recommend with Angular development on it, turn that flag on. And this is a pretty common place to turn it on inside of main.ts. This is right before the app boots. It's a static setting. And you can define multiple different types of vision hover options. That's covered in this doc right here. There are certain controls in visionOS that get hover styles by default, like pickers, things that are buttons, things that are kind of interactive on their own. But things that don't get it by default are like typical view layouts. And it's pretty common in Angular development where you may put a tap click action on, say, a div, for example. Well, grid layout with NativeScript and Angular, that's the same case. We want to wrap sort of a container around some UI, and we want to allow you to tap on that container. That container would not get a hover by default. So it's really important to sort of define a default hover style. So anywhere you place a tap, it's going to automatically get that behavior. And the actual behavior that you want can be defined here. So there's really only two types of shapes. You could use a circle. We can take a look at what that looks like. Yeah, zoom in here. You can see we get this circle highlight. Some cases of development, maybe a circle is nice, but obviously the rectangle is what we want for this case. But that is an option. And then we'll leave it as rectangle. You can adjust the corner radius. And then there's two different effect types, highlight and lift. And I haven't seen a whole lot of difference in cases with lift, but I think there's some UI cases where on the device and how you interact, you may get a slightly different effect there. But the difference between highlight and lift to me is not too distinguishable. So highlight is usually going to be probably what you want. But definitely you can play with these options and you can define as many of those as you'd like. It's covered here, where if you want different UI to have different effects, when you look at it, you can define different keys inside of these options. And these keys can be referenced as hover styles on any UI element. So any UI that you want to have a different style, when you look at it, you can set a different hover style and it will take on that particular effect. But yeah,
Question
I
for
think,
you.
sure.
I just noticing you mentioned earlier that we should turn off HMR and we use the no HMR flag, but I do see you making live changes and the emulator is picking up those changes almost in real time. How is that working? What's going on there?
Great question. Um, we often refer to HMR or live reload, which is slightly different. Live reload is it's reloading the whole app and sort of booting it again. HMR is just going to apply a change and patch it into the JavaScript and apply it without reloading the app. I'll show you the difference between the two. So I'm going to stop running this. And then, as I mentioned, if you're going to use HMR, you want to turn embedded flag off. That's important. You can't run HMR with the embedded flag on. So when we take this off now and we run this, and the live reload is pretty quick. I think for most development cases, like live reload is going to be pretty satisfactory. If you're doing a lot of acute like styling on screens, it's good to enable HMR because you can do some really fast, quick edits that way. But for example, so let's see what we got here. So you can see we got the highlights now. So I'm going to go back here and I'm just going to flip this to false. Let me see if I can rearrange my windows where you can see this a bit better. Let's see. And I kind of want you to see the terminal over here too. But you can see HMR is enabled here by this log. HMR is enabled. And then let me get the simulator over here. So I'm just going to hit save and you'll notice the difference here. So did you see it didn't totally reload the app? it actually just applied the JS change patch and then reload. And we can also see now when I do this, I get no hovers. And if I enable that back, let's go true, you can see they're back now. So that's the difference between HMR and live reload. Live reload's pretty quick. Like I say, it depends, it depends on the scale of the app too. A really large app that has like a heavy boot process, like maybe there's a lot of things happening on initialization, maybe Firebase is involved and you're initializing that every time the app boots and other connections that are happening on app boot. That's where live reload, may be just slightly slower because of all the things involved in booting the app. But yeah, we're going to touch on at the end of this debug mode, and it's really handy to have debug mode flags, as we all know in apps, but a debug mode flag is really nice in those cases because maybe you want to disable some features like that when you're just really focusing in on a particular view and maybe styling it. But yeah, so that is
the general rule of thumb here is use HMR when you're like kind of doing micro edits and like trying to move really quickly on a small thing. But when you want to make sure like the end to end's actually working, you should work in no HMR mode and trust the live reload is doing what you need.
right. And
Awesome.
let's actually see if we get a
There's also
live reload here. Yeah.
there's also a
So
question in the chat about HMR prefers state, but live reload does not, question mark.
say that one more time.
There's a question about state being preserved in HMR versus live reload.
Yeah, great question. So that's the other thing with HMR. Some cases the state is maintained and others not. A good example is like routing. Routing will generally not be preserved upon that HMR. And so you can end up in some state, cases. I think the great way to use HMR is set your route to boot where you want to detail. Like for example, if we wanted to work on this detail page, I'd probably set my default route to that particular detail, have it boot right there, and then every time HMR is applied, I'm like right on that page every time. I think that's a good way to use HMR. There are ways to enable routing through HMR, but it takes sort of a certain route setup, and it's possible the NativeScript Angular integration could offer something with HMR there uh, that would preserve the routing, but yeah, definitely some things to keep in mind. I think general rule of thumb, try with HMR on, see if it works for your case, and if it doesn't, live reload may suffice. Let me go back
Thank you for those
to,
answers.
yes, let me go back. I'm going to use probably, let me see if our settings are back to default here. Yeah, I'll leave embedded on for right now. And I'll get this back going. Okay. So yeah, we talked about this option in HMR. Let's touch on now Swift UI. This is where things get a bit interesting. So VisionOS being a Swift UI first class platform, there's a lot of neat APIs that are provided in VisionOS. One is Model 3D. Model 3D is actually given to us through this NativeScript Swift UI plugin. And in fact, Reality View is being worked on right now. We'll talk about that in a bit. But Model 3D is a really neat API. It allows us to place USDZ files into our app resources, which we'll show in a moment. And then you can load those USDZ files through a source property on the Model 3D. And you can actually change yaw and pitch, and you can change depth on it to bring it out and away from the window or closer to the window. We'll look at some of that stuff. And then the other thing about anytime you bring in custom elements, you want to use the register element from NativeScript Angular to make that available for use in your Angular components. So let's take a look at that. I'm going to bring this back bigger here. And we'll take a look at the detail component on this. And what we're going to focus in on is Model 3D here. Model 3D is an actual Swift UI view component. We're able to use it here in Angular because we register it through the NativeScript Swift UI plugin, and we're registering it right here in our root app component. So we're just importing Model 3D from Swift UI, and then we're registering it as Model 3D. This register element API is really simple. You can register any named element node to be used in markup, and then let that represent whatever class you want that to be. There's a lot of nifty tricks you can do with register element in this way in certain cases, so it's a really neat thing to know. But Model 3D has a pretty simple API because we can set a source. Right now I have it set to a binding. We can set the drag rotation dynamically. That's at yaw and pitch. That's left and up and down, which we'll look at. And then the depth is bringing it further out or closer. We can use standard tailwind styling to move it a bit. And we can dynamically adjust the size, based on the 3D model that's being loaded. So that is in here. I'm actually going to reset the camera position. And then, yeah, often when you're working in VisionPro Simulator, this is the case on the device as well, is that, often you may move around the windows. That reset camera is pretty handy. And then usually grabbing the bottom of the window will sort of center frame it back. But I always find this a bit too far away by its default settings. So I like to kind of pull in a little bit. Yeah. So we're going to focus on this screen. So Model 3D is being used here. This is actually a 3D model that's interactive, and it has lighting and all built into it. We can toggle this segmented bar at the bottom, and we can sort of explore these 3D objects. I think we have one more. And this is another thing, when you're on the device, it's easier to move around because you can it's a bit more of a dynamic environment in there. In the simulator, you're sort of at one vantage point. And so sometimes depending on, the size and shape of 3D things you're modifying, maybe you're blocked by the 3D object. So I'm actually going to see if I can move this down just a tad, and we'll get our telescope in there. So these are all USDZ files loaded into that Model 3D from the NativeScript Swift UI plugin. And that's coming in through here. This is the segmented bar at the bottom. This is built into NativeScript Core. It's actually a standard UI kit control. And it represents really nicely on iOS naturally, and also in VisionOS using the natural glass materials. But let's change the yaw and pitch to 200, for example.
While that's loading, question was, does NativeScript use the native Screen Kit API for the 3D models?
Native Screen Kit. Is that in reference to like Reality Composer Pro, maybe?
Not sure. Mark?
I mean, you added a 3D model on the screen, so as far as I know, the native way in Swift is using SceneKit. So I guess it's SceneKit. So is SceneKit also implemented in the iOS part of NativeScript?
Oh, good question. You can use SceneKit, it's an option, but the APIs on VisionOS are pretty nice in terms of like 3D interaction. So this is using APIs directly provided through Swift UI, and you don't even necessarily need SceneKit for these. If that helps answer the question. Yeah, SceneKit is a way you can as well. This right here, you can see, is a increased yaw and pitch, which is allowing me to interact with a much broader degree of left and right movement. I can almost flip it upside down, but that is actually acting on a drag rotation modifier in Swift UI, but we're just doing that through the Angular binding here on Model 3D. And we can do that for all the shapes here. So it's kind of neat to see that in full. See if I can get the telescope back in here. I should mention these 3D models are provided by Apple. These are part of the Hello World tutorial, and they're actually provided through a Reality Composer Pro project, and you can use Reality Composer Pro directly in the setup. I'll touch on that in a minute. Or you can even open Reality Composer Pro and export the models into USDZs and drop those into resources and use them like that as well. But yeah, definitely some neat settings in order to do that. Let me check and change the depth here. I'm just going to go back to 20. And I'm just going to take the depth to, let's try 100. And just so you can see sort of what's happening here. I'm going to reset my camera again. Go here. And it looks like it's a lot close to the window. And if I change the yaw pitch, I think some of them would actually encroach on the window in the back. If we were to look around it, I'm actually going to drop it down even to 50, and I'm going to increase the yaw pitch again, because if it's too close to the window, you'll see it actually starts to interfere with it. So this is definitely sort of a good way to get the right 3D. Yeah, you can see right there. So when the depth is not enough, and it depends on the 3D model, but obviously with a depth of 50, we're too close to the window, and that wouldn't be a good experience having your model cut off in there. You can kind of see that if we rotate around. You can see it gets us much closer. Yeah, you can see the moon's actually sitting in the window. Yeah, those are yaw pitch and depth. So those settings are nice to play around with and see what works for the 3D model that you're positioning in the setup. But the layout is pretty simple here in terms of we have a layout container that has a flex position on the top row for our 3D model. And then the bottom is just fixed at the bottom there for our segmented bar. Go back to here. Yeah, so let me mention resources here. So I was talking about the app resources, Vision OS here. Every app has this app resources file, and the platform name will be in here. So if you were developing on iOS, you'd have an iOS folder here. There might be an Android folder here. But for Vision OS, this is all the Vision OS specific stuff. You can see that in here, these assets are actually the same assets provided from Apple in the tutorial here. And actually, I think I do have the tutorial files down. Yeah, right here. This package that they allow you to download, which has sort of a complete Xcode project of this entire Hello World, breaks down a lot of these things that we can use. So resources, for example, contains these assets. Well, if you notice, these assets, go back here, I'm going to open this directory, and then let's look here. And we're going to look inside App Resources, Vision OS, and you can see these assets are also right here. And you can see these are identical. So these assets are the literal Xcode assets that are used, and you can use that from anything. So, any image sets from examples that are out there, you can drop them in assets and use them exactly the same way. Often how they're referenced is through a res colon / / So that looks like, let's see. I think we have a few in here. Yeah. Yeah, at the top here, we set, we're actually using Angular signals. and computed properties already in our bindings here. So this is a computed property that dynamically changes the background image between the globe or the solar, depending on what view we're looking at. And these resources are prepended with res://, and those are referring to literal names and assets. So we can see globe hero and then solar hero is here. And yeah, these are our assets in the Angular project. These are the assets from Apple. And yeah, we can use those as is. The USDZ files you can see are just directly in the resources. So app resources, VisionOS, we've got satellite, we have telescope here. These can be used as literal names inside Model 3D. So if we go back to detail here, this is bound to active model. Active model changes based on the view we're looking at. And in this app, I should say the setup of it is pretty simple in the sense that we have a single detail route, and that's it. When we go into this detail, it sets the current detail ID, and that defines the text and what we're showing. And then this is going into the same detail Angular component, and it's just changing up what we see with the background. So a pretty simple like app setup in general, but the active model is changed every time that we go in here, and that's why it's shifting what we see. And the other thing I want to mention about assets is that you can use assets in the VisionOS directory, or you can use them directly in the app's assets. So you kind of have the option of either. And it doesn't really matter which one you use, really. Like you could put them inside source assets, and here's like solar background. This is actually the image that's shown when you go inside here. That's that background that's back there. It has some stars in there, which you probably can't see too well through here. But that asset in the Apple tutorial is also here. I think it's the solar background image set. And I just wanted to split this one out mainly to show it as an example, because you can use either or. It just doesn't matter a whole lot. But yeah, when you're using it from source assets, you can reference it with the tilde, and it's pulling that ping from there. Let's see. The bindings in here, I should state, are driven by an Angular service. So the way that this is set up is there's a data service, and it's really providing all of the data for the whole app. This is really just for example purposes, but it's using the current detail then to set each page with the text here. And that's really all that's at play in terms of like data model from Angular here. Let's go back here and find my slides again. So yeah, that's assets. And I should mention anything that's inside this VisionOS folder typically is going to get built into the Xcode project. So when you do ns run VisionOS, it's actually invoking Xcode build on the command line for you, and it's building any changes in anything that you do inside of here into the Xcode project. And that's why it's always inherently available to you when you're developing the Angular app in here, because the NativeScript CLI is making that available to you. The source directory is what we're going to touch on in a minute, because the source directory allows you to drop any platform-specific files that you may want. And these are things like Swift UI directly. And you can interop with some of that Swift UI that's inside the source. You can develop solely in Swift if you want, or you can access that from Angular. The choice is sort of yours at any moment. So let's touch on some of that. Just make sure I covered everything here. I think we covered Model 3D well. Oh, yeah, one last thing. I should say the binding also provides a URL. So I'm going to go to another pretty neat page that Apple provided with an example, and these are the AR quick looks. We can take any of these and copy the link address. This is like some sample USDZ files that Apple provides to kind of experiment with. So I'm going to take one of these and we're going to go down here and I'm just going to change this to like this. And let's take a look at that. Let's run our app again. And you can use any HTTP URL as well as the Model 3D source. It's actually going to remotely load it over the network, pull it down, and then display that. So now if we go into, reset my camera one more time. We go inside here, it will remotely load it, and then we get that 3D model here. And so you can, of course, include remote USDZ files. They don't have to be embedded in the app. USDZ files can be pretty big in size. So if like app size on the app stores is of a concern, maybe you want to host all USDZ files remotely on a CDN and just display all those remote URLs for your models that way. So yeah, I wanted to make sure that was clear. Let's go back. I'll leave that the way we were. So let's talk about this Hello World Apple tutorial. I want to talk about Swift packages, and it contains a Reality Composer Pro project, and we can kind of take a look at that and what that means in the scope of this. So often, excuse me, at least in a lot of examples that have been shown on samples with visionOS, often include a Swift package which isolates the Reality Composer Pro assets from the kind of project as a whole. It kind of allows you to deal with Reality Composer Pro as a separate thing and deal with all your assets and then include that in your project. And of course, we can do that with Angular and NativeScript as well. So if we look at the tutorial that Apple provided, that is this one here. Inside, we're going to see this packages folder. And this packages folder has a world assets, and we can see it has a singular package Swift. Now, I know for a lot of Angular developers and really developing in general, you know, it can always be a bit fearful when you're brushing up against a different language, and I totally understand. What I'll say is in this realm, you can take advantage of a lot of neat things that Swift provides and keep it as much in the Angular world as you want, or you can sort of mix and match the best of both. Again, it's sort of up to you, but it's good to understand some basics here, especially since visionOS is a SwiftUI first-class platform. Package Swift is Xcode's package manager, so you can include third-party Swift packages into your Xcode project through Swift Package Manager, and it's often defined by a package Swift. So usually if you see a package Swift in some code, that's usually a Swift package related thing. So it sort of contains all this Reality Composer Pro contents, which is a lot of 3D assets, and they're pretty big. I think the entire size of this is maybe 140 megs. So it's something you wouldn't necessarily want to push to maybe your GitHub repo, perhaps, but maybe keep it as a separate repo that developers would pull down if you were going to use some sort of Reality Composer Pro include. You'll see in here USDA files, and the USDA files are representations with all the materials of these USDZ files. So USDZ sort of encapsulates it all. Reality Composer Pro is sort of your raw setup of these models. You can kind of go in and tweak the materials. You could add dynamics to it, collision objects, lighting components, and things like that. It definitely starts to teeter into the 3D world a lot. But we can include that package in our Angular app by putting a reference to it. So you can see inside of the Angular app, there's that same packages, and then there's world assets. There's our Reality Composer Pro project, the package Swift, and that's the same folder that Apple provided from the sample here. And then the way to attach that to our Angular app is through the NativeScript config, and it's through the VisionOS property. And this is where we can define anything specific for our VisionOS build. And there's this SPM package. This is Swift Package Manager, and we can give it the name of the package, which is world assets, and then the path to it. And it's just the local packages path. NativeScript CLI will pick that up. It's going to attach it to our project, and we now have access to everything that's in that. Let's take a look at some things in there. And we'll do it first from here so we understand what we're even dealing with. This planet Earth has a lot of things attached to it. It has like a rotation component, and it has this menu. It has a lot of these sort of different features you can do with it. All this is coming from that Swift package in World Assets and Reality Composer Pro. We're invoking it through the NativeScript Swift UI window manager. So let me show that first before we dive into the details of the package itself. So this is on the detail component, and we're calling open window on this button. This is the layout container for this page, and this is the heading. This is the heading label that shows Planet Earth. This is the description text with text wrap on it. That's why this text is wrapping for the description. And then we have our view globe button here, which is a computed signal property binding for view globe, view outer space, or view orbits, depending on the detail view we're in. And then we're calling open window. Open window is using this window manager, and that comes from NativeScript Swift UI. We have a window manager and an XR object. XR deals with immersive spaces, and we'll take a look at that in a minute. But window manager we can use to get a reference to any of our scenes in our Swift UI base. So this is where it gets pretty neat, because this whole time we've been running this app, at the very beginning I mentioned the embedded flag is important because we're actually embedding our Angular app into a Swift UI first class lifecycle app that's happening by way of this NativeScript app Swift. So this is the app lifecycle that gets booted, and then our NativeScript main window is our Angular app that we've been building and looking at this whole time. We can, however, make the app more dynamic by including more window groups. We can include immersive spaces, and then we can interact with these things in a number of ways. If we're comfortable with Swift, we may do that totally inside of Swift, which you can inside here. I'm actually including a lot of Swift from the Apple tutorial here just to show how deep you can go in terms of that. But you can also embed NativeScript views inside of Swift UI views. So the interop is pretty fluid. And inside NativeScript views, of course, you can embed Swift UI views. So this can actually be a NativeScript view that is open in a totally separate scene that can also embed Swift UI things in it and other NativeScript views. So it's, again, a lot of options on how you can do it and different things you can do, but we'll take a look at the setup of this and how this works in a moment. But also, let me describe this API for a minute. So window manager get window is the API that you'd want to use when you're opening any separate scene. And a scene is going to be anything that's defined here. So this is like scene 1, if you will. Anything that is enumerated here, you can ID, and you can open it by its ID by that API in Angular. So window manager, get window, we're going to grab the globe. That's the name of that scene for this globe here. And we're just going to call window open. And that's what opens this separate window we can kind of move around. It even has its window bar here. Just going to close that. Windows are pretty cut and dry in terms of it's a window group. There's a window style. You can define sort of plain window style. You can do volumetric. This globe that we were opening was a window group, but it was volumetric. And so you can define sort of the default size of volume of that. So when that globe is being open, we're setting sort of a default 0.6 of sort of the size of that. Immersive spaces are fully immersive or mixed immersive. Most people who've had some familiarity with AR for a while are familiar with the mixed reality. That's where you have sort of 3D things coming into your own world, but yet you're still in your world. Immersive spaces that are full are completely outside of your realm. So you leave your world and you're somewhere else. And we have a mixture of both of those here. So if I go to orbits and I do view orbits here, this is an example of a immersive space that is mixed. And it's mixed because we didn't leave our room. We're still in this room. And this is not a flat window because you can see there's no window title or bar below it. So we don't deal with it like a window, but it's actually an interactive, 3D piece that's now in our world in the goggles, of course. But we can move this around and deal with it sort of on its own. And you can have as many of those sort of open there. Immersive spaces that are full are completely immersive, and you can only have one open at a time because it is fully immersive. But if we view outer space, this is going to prompt us here with a standard warning that, hey, you're about to be fully immersed. And now we enter this fully immersive world where we can take a look around here. We've got the moon over there. We've got the sun over there. And, we can look totally 360 in space here. And, obviously in the simulator, you only get a sort of a sense of what that's like. But in the goggles, it is pretty impressive. We're going to exit out of here. And we can toggle out of that immersive space back. That's all happening through the definition of these. So these are just defining the different scenes we can interact with. And then it's all being opened through either Window Manager for Windows that are flat, or we're going immersive through XR. And so we can request an immersive space by its name and open or in that session. And that's how we're interacting with that. The very important detail on multiple scenes, when we get to that, is this property in the info plist. This is a very important property, and everything will fail if this is not set. So if you are going to interact with scenes, multiple scenes in the Angular app on VisionPro, you would want to set this property in the info plist. That makes sure that you have access to all those different scenes. So now I think we can swing back to this Reality Composer Pro after seeing what we're getting from it. So I'm going to open the actual Xcode project where we can see this for a moment. And it'll also let us open Reality Composer Pro. At any moment, at the base root directory of the Angular app, you can run ns open vision.os. It's going to open the actual platform project here, and we'll see this package dependency. This is the world assets that we included here. So that's our Swift package being included. NativeScript CLI is building that into the project for us. And this is the Reality Composer Pro file. And you can see that's our moon. And the moon all of its lighting materials and everything are in Reality Composer Pro, but we can also export those files into USDZs and put those directly in our resources and use those in our Model 3D that we were just looking at. So anytime you view this here, you can open in Reality Composer Pro. And we will see here, we have a lot of assets in here. There's a lot of detailed materials and settings for these different 3D objects. But we could take Earth or telescope here, and we can go File, Export, and we can export that as a USDZ. And so you can see that's what I did for the moon and the satellite and the telescope, is I just exported them from Reality Composer Pro into USDZ file, placed them in assets, and I'm referencing those. And that's what we're using inside of our detail screen back over here. So these are the USDZ files from resources. USDZ files are probably the easiest way to interact with 3D models because it's sort of all encompassed. There's a lot of detailed, fine-grained details you can get into with Reality Composer Pro that I won't cover here because it definitely starts to get into the depths of 3D modeling and a lot of 3D, characteristics, but I definitely welcome anyone to sort of explore around Reality Composer Pro. A lot of different programs can do 3D, 3D Studio Max is used a lot. Lightwave, I used to use years ago, and even Alias Wavefront when I think it was owned by Alias at the time, Maya, which is a really neat 3D modeling program. All of those would work for this kind of work as long as you can get a model out to either USDZ or you can bring the materials in Reality Composer Pro and deal with them there. But yeah, that is Reality Composer Pro in a nutshell as far as interacting with it. So this package itself, we're interacting with some of this by way of the Apple tutorial file. So a lot of the Apple tutorial that we're using in our project is inside of source here. And because it is a VisionOS project, it works as is, meaning everything that's stated in that Apple tutorial works as described. We're basically invoking those things and opening those scenes from our window manager XR from the NativeScript Swift UI. Let me go back over here. So yeah, again, SPM packages can be included this way. Any SPM packages, by the way, you can get a lot of materials or a lot of great open source libraries for use in VisionOS, even growing. And iOS, of course, you can include them in any project through SPM packages. And we touched on the scene manifest. So again, very important property, multiple scenes. You want that set to true. And exploring the NativeScript app Swift, I'll just touch on that for just a moment longer here. Make sure it is clear. Every Angular app on VisionOS is going to have at least this setup. It will at least have a NativeScript main window. And that's primarily your 2D window surface that you're going to interact with the most. And then again, opening any number of scenes that you want to do around that, whether they're 3D objects floating in space, whether they are interactive scenes in windows, totally up to you, or immersive spaces. But you typically define those here, and then you can open them and interact with them. So let's look at this case. So this case is a NativeScript view that we actually developed and built inside of the Angular app, and we're actually going to use it here inside of a Swift UI window group. So this is us actually embedding a NativeScript view into a Swift UI scene. This all, again, comes from the NativeScript Swift UI plugin. So at the very top here in our data service, it provides an API called Swift UI Manager, and it's called Register NativeScript Views. This is an API that allows you to register as many components that you want to open in scenes or embed in Swift UI. I should note this actually isn't isolated to just Vision OS. This is used for any time you want to embed NativeScript views in Swift UI in general. So it's not just VisionPro here, but if you want to say this component, this Angular component, which has this layout with a label, and we've got an image here, we've got some animated properties, and we've got some color changes here. If we want to open this inside a scene, we can use that API, register native views, and we can give it a key. Often the key is going to be the name of the scene that we're going to open. So my custom scene, window group will always have a matching ID. And then the ID inside here does not need to match the scene. I'm just doing that for clarity here. But the ID just has to match what you provided here. So my custom scene is going to be bound to scene component. So we can now open this Angular component inside of a Swift UI structure. The two create and destroy is an additive API for Angular specifically. And this allows us to have a clean life cycle. This is actually a flavor agnostic API, meaning it works across anything in JavaScript. And so it allows any unique flavor specific interaction with NativeScript to actually key into that and do some detailed life cycle. For example, with Angular, we're going to keep track of component refs, and we're actually going to take an injector and generate a NativeScript view from that Angular component. And then that Angular component gives us reference to a view. This view becomes embedded in Swift UI. And then when it destroys, when we close that window, we make sure our component refs are actually cleaned up. So this is really a way to integrate any custom lifecycle that you want in to take care of any memory cases that you want or anything specific that you want when your component is created or destroyed. So let's take a look at what that looks like. I'm going to close Xcode here now. I'm going to go back to our detail view, and we're going to swap this to open our custom scene now. So if I look at open custom scene, again, we're using the window manager. We're going to get the window by my custom scene. This is the key that is actually defined here. So we're actually getting our scene, my custom scene, that we stated there this way. And then we're going to call open on it, which is going to open a totally separate scene, a window in Vision OS. And inside of it, it's going to have an Angular component. So let's take a look at that. I'm going to run it this way. Make sure we're back centered. And this is going to open from the detail screen on Orbits, I believe. So we're just sort of using that as an example. But this right now should open JS drops. How about that? Yeah. So, you know, this is a Swift UI window group with an Angular component in it. And the Angular component has all the things that we would expect, but you can interact with this window natively to the platform. You know, we can resize it here. It's resizing naturally, meaning it truncates the label as stated, and you know, all the animation is intact and those sorts of things. So that that is happening through scene component here. If we take a look, we're using a setup here where when the label is loaded, we're attaching a interval that fires every 2 seconds, and it's changing the color. That's what's changing the color. This is just sort of a silly contrived example, but just showing you that all the JavaScript that you do inside your Angular components intact here, you know, from a Swift UI scene, and all the animation that we attach to it is also intact. So we're sort of animating the label backwards and forwards, and then we're scaling the image up and down, and then the color is changing there. And the background color is styled in, Tailwind. So we've just got sort of a rounded 24 pixel window background back there. That's coming from Tailwind styling. And the gradient JS drop is just a custom gradient I put inside of app.css. It's just sort of a background linear gradient that has the orange to purple, there. So that's pretty neat. The depth of this at which you could go is pretty deep. You could have NativeScript views with, say, other 3D models. So let's do that. So let's take a 3D model, for example, and let's put that inside of our component here. I'm actually going to I'll replace these with this. And this is going to be that gramophone. Actually, let me see if there's a neater model we could use. Let's do the strat. Let's take that one. And I'll go back over here. I'm going to close this. And let's save that. So I'm going to use a pretty increased yaw and pitch there so we can sort of fully circle it around. And let's go back here. Let's do this. And let's see, it should be loading remotely a URL, and take a look at that. And now you can see here's where the depth and the size comes into play. So we've got a window, and if we look at our definition of that, we've got just a plain window here. That can actually have size, like a default size on it when you open it. So you could actually open it like much taller, or, not as wide either. But I think we're just going to sort of play with the properties of the model itself. So maybe we'll go, maybe we'll make it quite a bit smaller, maybe 200. And let's see, the depth is about right. It's a pretty big model for that sort of window. We can also take the gradient back off of here, and this will make it look more like the model is sort of sitting outside of a sort of gradiated back there. Let's see if I can get that open again. There we go. Now it looks like it's sort of free floating on its own, right? So kind of zoom into that. Look at that better. Get over there to it. These controls are much easier to use in the goggles themselves, but yeah, so this right here is sort of interesting because this is a NativeScript view Angular component that is being opened in a SwiftUI scene with a Model 3D model in it, which is SwiftUI. So it's actually a NativeScript view open in SwiftUI with SwiftUI in it. So the interop is pretty wild in what you can do. But yeah, so that sort of gives you an idea of maybe what's possible there. I'll go back.
Watching that, I almost feel like IKEA has their next big idea already in the works, like designing that room with their furniture.
I want to see it. It'd be so fun. It would be fun, especially all those rooms you see right when you walk in.
So much easier.
Yeah, it'd be pretty fun. Let's see. Let me go back to the slides here. So we talked through sort of the NativeScript app Swift. It's just important to know we often refer to that as the app lifecycle or the main boot file. That's actually the file that's responsible for booting your NativeScript Angular app on visionOS. And so it's sort of the heart of it, meaning you can sort of define sort of the key high-level characteristics of the app there. And that's why knowing a few things there doesn't hurt, because you can do a lot with that. But you can kind of choose how much in depth you want to go into one or the other. If you're comfortable with SwiftUI, certainly you can do that inside of here. And And what's neat about the way that that works, if you're going to go that route, is that if you use NS Open Vision OS and you open the platform project, all of the Swift UI files that are in here are in NS native sources. So this is NativeScript native sources. This is everything that's included in the source directory. And this is auto-linked. So the neat part about this is that if you want Swift type checking here, you get it from here. But as you make a change here, it's actually, I forget, I think it's default size. Yeah, default size. And that's where you could change this to like, maybe you want it 400 by 600 since it's a strat and it's taller than it is wide. Maybe you want to open it by default that size. Well, as you make that change there, it's actually auto-linked and you can see it actually updated inside of our Angular project right away. So everything that you do in either world is in sync with each other. So whether you do it here and you know it offhand, or you want to use the aid of Xcode Swift IntelliSense there, you can do it there, and it auto links here. When you run it back from NeoScript CLI, it's always going to include that. So that's sort of up to you on how you want to interact with that. But you know, everything that's here from the Apple tutorial you can develop as is, as stated there. So if you wanted to get into the details of the collision objects and some of the way the rotation spheres work, there's a lot of geometry and math that's going on in some of the like auto rotation settings that are set here. One of the key elements that's happening in a lot of the immersive spaces is reality view, which reality view is a Swift UI construct that is being worked on right now in NativeScript to make that available to Angular directly in the same way that Model 3D is. So Model 3D is a construct from here. So if we look at Model 3D Apple, we can see this is part of Reality Kit. But this is what we're interacting with in Angular. You know, so when we're setting the source and we're setting the drag rotation, we're actually interacting with this directly, but we're just doing it from here. You know, but that is actually the that is the element we're interacting with. Let me get back out of here. And go back here. So yeah, we talked about this. This is the Swift UI Manager, registering NativeScript views. Again, anytime you want to use NativeScript views in Swift UI, you can register them by a key value, and it's just the key name that is being referred to here. And again, these don't need to match. This was just an example where I matched them, but this ID is important for the window manager. So just to reiterate, we're using that key here. So when we use the window manager to open that scene, we get it by that ID, and then we can open it that way. Whenever we're embedding NativeScript views inside, we can use NativeScript view, and that ID is what's used with register NativeScript views. And so that's the ID there. And then this is just pointing to the Angular component that we imported. And this is a standalone Angular component with, you know, standard JavaScript in here to interact with it. So let's, I know we're getting closer on time. Let's end here on the title sequence animation. So this whole time we've been interacting with this app, I've actually had the debug mode flag on. At the beginning, I mentioned, you know, I know a lot of us in apps, we often use, you know, the dev, whether it's from Node or we're using either feature flags to sort of turn things on and off. I've been doing that same thing all along here for the title animation because as you'll see here in a minute, the title animation is not something we want to interact with when we're developing this app on a regular basis because there's time involved with it and we don't want to wait for it every time. So I'm going to go to the data service and I'm going to turn debug mode to false. And let's launch this again here and make sure. Yep. So here we go. And when this launches, we should see the full title animation. So in Apple's tutorial, they used a really nice and elegant sort of intro animation as it starts. And that animation they actually did through a text Swift UI component using a custom type modifier. Modifiers are neat in Swift UI, but you can actually do that same stuff with JavaScript. And so I just created the same animation for Angular using JavaScript here. We'll take a look at it. So you can see we get sort of a cursor and it types out hello world, then it fades in our scene. Pretty nice and elegant way to launch into the app. And that is done pretty simply. So we're actually using, go to where it is, right here. So we have a single layout that's sitting in the center of the screen. So this is sort of a grid. We've got two images here. That's the sun sliver at the top, and then we've got the earth half down here. And they're sort of positioned on top of each other with sort of just some settings to make it look nice there. And then we have our titles that are sitting in the middle. And what we do here is we're loading a hello world. This is like the complete full title already specified out. And when loaded fires on it, we're actually setting the opacity to 0. And that's why we don't see it right when it loads. So this is loaded full title here. And this is where I use that debug flag. So if debug was on, we sort of skip the whole animation. And that way we can develop faster and not have to worry about that every time. But when we turn that off, it's actually going to set this in motion. So it sets the full title opacity 0. And then we have this label here with no text on it by default sitting right above it. This is sort of a neat aspect of grid layouts because they sort of act like a canvas in a sense that you can layer views on top of each other. And this is a label with the exact same settings sitting directly on top of an invisible label of that text. And so right when it launches, we actually begin this sequence and loaded title kicks it off. So we set the initial text to that pipe character, which is like our cursor. And then we start it after basically about 1.2 seconds. We start this sequence, and we're using standard async await, JavaScript syntax on this. But we're going to grab the underlying UI view, and we're going to start to do sort of a fade in and out, and that's what's creating that fade in and out on the cursor. So let me do that one more time. You can see that again. So if you'll notice, we get the typing right there. That's a fade in and out, and then it types it out, and then you can see it fades. And so this is the fade in and out on the cursor. After the last fade, we then type the title out, and the title itself is just happening here inside of an interval. So every 200 milliseconds, we're basically concatenating the title for Hello World to the end, each one character at a time, ensuring the cursor's at the end. This is the same thing that Apple does in their SwiftUI Hello World tutorial, and they just do it through a SwiftUI modifier. So again, the choice is yours. We could even include SwiftUI in that modifier directly and put a SwiftUI view right there that does that. So for example, we could like comment out this whole thing. We could put SwiftUI here, and we could give it a Swift ID of literally that title sequence that comes from SwiftUI and put that there. It's an option. Or we can animate it and do it ourselves, with pretty standard JavaScript syntax. Again, it's just the choice is up to you on how you want to do things. After the text meets the full length of the Hello World text, it then fades in everything. So this takes the title, and we're sort of fading those labels out, and then the background and the rest of the UI is fading in. So, but yeah, it's pretty straightforward that's happening there, but definitely a super elegant effect and nice kind of stuff to do as you're, in sort of those production polish moments for the experience.
That's pretty sweet.
So yeah, all this, by the way, is on a repo. So I put this up on a public repo. It is at VisionPro Angular, and people can definitely play around with it. Just everything we went through here. The only prerequisite is that you want to include that packages, and because it's big, like I mentioned, it's like 140 megs. You want to download that and then place the packages folder in the root, which is what I've done here. So if I close everything again, you can see packages is there. So yeah, if you download that, put packages there, then you'll be able to run it just as we've been doing here. And you'd be able to sort of play around with that. The detail component, again, on the embedding NativeScript views in Swift UI, which honestly has not been shown before. This is sort of a first for that. So hopefully some docs will go up illustrating that with some more even in-depth usage cases of what you can do with that. But the detail component can be changed from open custom scene or open window. Those are sort of two examples that I put inside there where you can either open the existing sort of immersive scenes and the 3D globe, or you can open the custom scene, which is a NeoScript view inside. And that is opening that singular component. But yeah, that without going too heavy-handed, I don't know if that was too much information, but hopefully that gives everyone a gist of what is possible with Angular on Vision Pro. And I'll share with the group, there is a Vision Pro Angular app that's being developed for Vision Pro right now. And we hope to have it released sometime in the fall, maybe. So, excited to share that with people when it's ready. It's in the depths of development at the moment. So, but have fun with this stuff. There's a lot of neat things you can do, and it's a neat device. I have enjoyed it.
Well, Nathan, we got a few questions in the chat for you if you still got a few minutes.
Sure.
There was a question earlier as you were showing us sorry. If they're Jamie, I'm sorry. I need help with your question. It was a question regarding using Blender and creating some of these elements. And I'm
Yeah, I was just curious if there's like already plugins that have been released or whatever for like exporting to these Apple formats, or if like there's like a more convoluted way of going about it.
It's a great question. USDZ seems to be the format to interact with, and I know all major 3D programs export to USDZ, and if they can't, they can get it to a format that you can then drop in a converter to get it to USDZ. So I think in general, it's safe to say USDZ is a great way to go for a large amount of 3D interaction. Now, where you start to get outside the realm of that is when you get into collisions, particle emitters, which we didn't touch on here, but hopefully sometime this summer, there'll be some more docs up on that. There is a blog post that's up on using particle emitters on Vision Pro in this kind of development. But that's where you may want to be more in Reality Composer Pro and back, because you can do everything you can do in Reality Composer Pro in code. So you can attach, collisions and particles and stuff. You can do all that inside of code, or you can do it sort of interactively in the Reality Composer editor. That's the kind of stuff that gets outside of Blender, because if you model something in Blender and then you want to bring some interaction to it, like particles or collision effects, that's the kind of stuff you'd probably hook up inside of the actual, Angular app. Once you bring that in, get your USDZ in, and then or maybe bring it directly into Reality Composer Pro and attach that stuff to it.
Yeah, that makes sense. Thank you.
Blender, I think, is a great way to model for it, though, for sure. I think, as we all know, 3D is its own world. A lot of exciting stuff there, but you can go pretty deep in all that.
And then another question from from way earlier. I know we've been primarily focusing on the Vision Pro with Angular and NativeScript, but as some of us know, NativeScript is very good for also building iOS and Android applications and is flexible to that. How easy is it to take existing Vision Pro code and backport it into iOS? And maybe the reverse of that, how easy is it to take existing iOS code and port it to the Vision Pro?
Great question. You can right now today take an iOS app that has iOS and Android in it, an Angular NativeScript app, and you can add the VisionOS platform to it. The best way to do that is probably through creating a VisionOS project and then just moving the source platform in. So that would be like, go back over here, right here. If you had a Angular app today and it was on iOS and Android, you would want to bring this VisionOS folder in. And once that's in there, you can then run ns-run VisionOS, and it would actually use that to run on VisionOS. Surprisingly, a lot of it will work as is. We found a lot of apps will run just as is. It depends primarily on plugin SDK usage and probably CocoaPods. A lot of CocoaPods you get through plugins, and a lot of them have added VisionOS support, but there's still a few that probably don't, and so you might run into something there. In those cases, you can either disable that plugin when you're running on VisionOS, and that's a way there. They deprecated some APIs in VisionOS, and most of that is you're already going to have adaptations and fixes in that in NativeScript Core, because NativeScript Core supports VisionOS today. So when you run an iOS app right now, it's going to use the specific window key APIs for iOS and iPad and that sort of thing. But then when you run on VisionOS, it's actually going to use the SwiftUI boot that uses a like Windows scene delegate and things like that. So you should be able to run it though, just depending on the size of the project and plugins. The app that we're working on VisionPro right now was originally developed for iOS, and we ran it on VisionPro with a few minor tweaks with plugins like that. So yeah, I think the process would be just create a Vision OS project using that create command here, and then that'd give you the harness there, and then you can move the Vision OS folder into app resources. And then at that point, you could probably just try running ns-run Vision OS and just try to run it on the Vision Pro simulator and see what you get. Yeah.
That's pretty cool. And then last question I'm going to ask. I happened to play with the Vision Pro last weekend. It made me a little nauseous, not going to lie. I had some frame dropping
Sure.
when I was doing the demo, and I was like, ooh, this isn't super great. And I know we worked on another project where we were doing similar things with React Native and 3GS and trying to get all of that simulation working, and we were seeing similar kind of frame drop issues inside of it wasn't the Vision Pro, it was the Vive and the Oculus and a few other devices. So I'm just kind of curious, have you seen any like performance things people should be aware of as they're trying to develop with NativeScript and the Vision Pro? Are there any gotchas?
Yeah, these are great questions. I mean, I think just a general comment people have had on like hand tracking. People say the hand tracking is like has some latency there. I found the hand tracking to be very good, but I know what they're referring to there, but as far as performance issues on Angular apps running on Vision Pro, I think as long as you're using the built-in controls, you're going to see great performance there. I think the common best practices apply where you don't want to use, say, an app for, loop in Angular for a big, large list. The reason being is that you're creating many view elements when often you don't need to. You really only want to create what's visible in the viewport. Typically use a list view or collection view for that. Those are the common things, I think, and just make sure that, especially if you're embedding NeoScript views inside of SwiftUI, you want to make sure your life cycle is set up right, which is sort of demonstrated in this sample here. This is the same create destroy that you'd want to use on any Angular app that's going to embed NativeScript views and SwiftUI scenes. This will make sure that those component refs are created and destroyed properly. So as long as those things are intact, you're going to maintain a pretty tight setup there.
That's awesome. Well, Nathan, thank you so much for joining us today. I know you had a slide up already, but you mind repeating, where can we find you on the internet? What's going on next for you, and what should we look forward to seeing you in next?
Thanks so much. Yeah, the repo for sure, if you're interested in exploring what we just talked about on GitHub, on my GitHub, VisionPro Angular is a repo that's public now, and you can explore everything that we just went through. I'm on Twitter at www.alkerrun. I'm actually headed to LA tomorrow to Cinegear, which is on the Warner Brothers lot, to actually demo a NativeScript app there Friday. And then we're back Saturday. And this summer, we are in the midst of VisionPro development on this app. So definitely a lot of VisionPro ahead for me this summer. And we'll share as much as of our findings that we can, through blog posts or, examples. We really want Angular developers to enjoy this stuff. So definitely explore and have fun with it.
Amazing. Well, thank you again for joining us. And as always, everybody, we hope you enjoyed this training with us, and we'll see you next time.
Thank you so much.
Sometimes it's hard to bridge the gap between business objectives and tech implementation, and it can get messy. This dot is trusted by top names like Meta, Google, and T-Mobile, and they love helping business leaders fulfill their strategic digital initiatives. Check them out at thisdot.co. One more time, that's THISDOT.co.